Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ifwat bin Shamsuddin, and inshallah today I will be showing to you about the problem, this maximum subarray, the idea of the problem itself, and how do I manage to solve this problem. Okay, so first let's look into the problem itself. So as you can see over here, it stated that we define subsequence as any subset of an array, and then we define subarray as a contiguous subsequence in an array. So given an array to us, find the maximum possible sum among the non-empty subarray and non-empty subsequences. And then we need to print the two values as a space separated integers on one line. So that means from this question that is given for us, it's going to give us an array, and then what we need to do is we need to find the maximum possible sum for the subarray and the subsequences. Okay, let's look more into the question itself. So they gave us a function, the max subarray, and then the parameter is just this array itself. Okay, and then what we need to do, we need to return a list of integer with size 2, and then it will be containing the maximum subarray and subsequence sums. Okay, so it's given for us the input format, which is not going to look at. This is the constraint of the input and everything, and this is the important part. The subarray and the subsequence you consider should have at least one element. So that means we cannot return 0 or null in our list. Okay, that's good. So we already know that we just need to find the maximum possible sum in the array for subarray and subsequences. So first, let's try to understand what is subarray and subsequence. Okay, to understand what is subarray and subsequences, I bring up my handy dandy friend Paint over here to explain it to you. So for us to understand what is subarray, we can just understand what is subsequence first. Subsequence is any subset of an array. So for example, if we have an array over here which size of 7, yeah, 7, we have size of 7 over here. So to create a subsequence, we just basically take any part of the array, any subset of the array, and then will become a subsequence. For example, let me just mark it for you. For example, we just take over here element of 2, 4, and then 6, right? Okay, we just take these three element, 2, 4, and then 6. So if we take those three and then we form a new array, and then that become a subsequence of that array. Yes, that's easy. Then what is subarray? Subarray is a contiguous subsequence. That means if you're going to take from 2 until 6, from 2 until 6 over here, you're going to need to take each of the element across it. That's mean you're going to need to take the 2, the 3rd, the 4th, the 5th, and the 6th element of the array. And that's how subarray is. So basically, subarray is you take everything from 2 until 6. Meanwhile, subsequences, you just can take the 2 and 6 itself without any of the other element that is between them. That is the difference between subarray and subsequences. Now, we already understand how subarray and subsequence work. We just need to find the maximum possible sum in it. So let's split that into two. Let's just try to focus on the subarray first. Why? Because for the subsequences, it will be pretty easy and you will understand it why later. Okay, so the brute force approach for a subarray problem, I think that would be the easiest way to to find the maximum possible sum in a subarray. What we can do is just basically we just add each of the elements in the array, and then what we can do is that, for example, if I split this into 2, what we can do is that we can just basically try to compare. If we subtract for example, the first element of the array, and then we compare by subtract the last element of the array, and then we will see that, okay, which one is bigger, either this one or this one, the one that without the first element or the one without the last element. Why do we do this? Because we are looking the maximum possible sum in a subarray. That means any other part, it should be contiguous. We mean we need to take each one of it and not any loophole, any hole in the between of them, basically. So from the brute force approach, we can see that we can do it this way, but then we still need to consider that, okay, if it's this ID2, it would be pretty easy. But what if we also need to consider that it might be just like this from the second until the sixth of the array, and then it might be from here, or might be from here. I'm sorry, like from here. So we need to consider a lot. It also might be like from the first until the fifth. So it could be everything. So, but the most important thing is that it need to be contiguous. So that is how we can solve this problem if we're using a brute force approach. So when I'm seeing this, what I'm thinking of is that we can solve this problem dynamically by we just storing the summation of the before elements in another array. So this sounds like an idea of a coin row problem. It looks similar, but I wouldn't be agree that if it's the same problem. So how's that work? Let me just give you an easy example. So if we have if we build another array, right? And this is the original array that we have on top over here, and this would be the DP array, which is basically the dynamic programming array that we're going to use to store the previous summation that we have. So from here we can take that the first element of the array as the subcase, like that. And then for the second part, what we need to do is just need to find the maximum between the element itself added with the previous element in the DP array, or the element itself by alone. We just need to find which one is bigger, because if the addition of the current element in the array with the element before in the DP array over here, if that's bigger, that means the starting point of our subarray is the element before. But if the current element is bigger by itself without any addition with the before elements, that means the starting of the subarrays will be here. So from that, you already got the idea, right, on how to solve this subarray problem. And this is considered as a dynamic programming since we already store the previous result of the summation of the elements before, so that we don't need to recalculate the elements before each time for it. So that we already managed to solve for the subarrays. Then what about the subsequences? Okay, remember when I said that subsequences is just, we can just take any subset of the array. We don't need to consider like the element between of it. We can just take out any of the element that we want from the array. As long as it's from the array, then it will be considered as subsequence. Then that will be way much more easier. Why? Since we just need to find the maximum possible sum, that means what we need to do is just we take the positive number of the array, and then we add all of them together. Why? Since if we add positive number, what we had is just going to be a much more bigger positive number, which is basically the maximum sum. If we add a negative number, then that means it's going to be decreased, it's going to be subtract, which is not the maximum possible sum. So we already have the idea of how to get the maximum possible sum and for the subarrays and subsequences. Okay, now let's look into the code. Okay, now to look at the code, it will be very much more easy. This is definition of the function that we have, and then what I did is just basically I initialize the array for the dynamic programming that is going to store each of the result before, and then the result itself that we're going to return later. So for every element in the array that already given for us as a parameter, and this is to comply the base case, which is for the element 0, we're going to just copy it without any summation at all, which is the best case. And then for the other than that, we're just going to find the match between the element itself in the array. We add with the previous element in the dynamic array, or just we take the element by itself, which is explained before. And then from that, and then this loop is going to continue until it reach the end of the array. And then we see also over here that is included in the loop, which is basically for us to solve for the subsequence, which is if the element of the array is positive, we're just going to add it into the subsequence total or a summation. But remember that when we look into the problem, like we can see down here, it stated that the subarray and the subsequence you consider should have at least one element. That means we cannot return 0, right? So if we look back for the subarray, it would not have any problem since it would take the max value from the array, or we can just take the base case. It's not going to have a problem. We're going to have a problem when it's going to look at the subsequence. Why? Because from our line of code, you see that we only take positive number to add into the subsequence result. Then what if the array that we receive is all negative number? What should we do? Then for that, for us to combat that case, what we're going to do is that I just added another extra if conditions, that if the result, which is the result 1, which is the result for the subsequence, is still 0 by the end of the loop, is still 0, that means what we're going to do is just going to take the max value from the array. Since if the condition comes out true, that means the array that given to us is all negative numbers. So if we take the one element, only the max element of the array, that is the maximum possible sum of the array. Because if we add two negative number, what happens is that it's going to just get lower and lower and lower. Basically, it's just going to be further away from 0, just going to get subtracted down. So if we have all negative number, what we need to do is just need to take the maximum element of the array, which is possibly is the closest number to 0. And that's what we do over here. And this is for us to get the result for the maximum possible sum for subsequence. And then over here is for us to just get the maximum possible sum for the subarrays, which is basically we just take the max value that is available in our dynamic array, and then we just return the result. And that's it. That's how you solve this problem. If I just click on this submit code over here, we can see that it passes all of the test cases. And that's how I managed to solve the maximum subarray problem. Thank you for watching. I hope all of you guys are able to understand the idea of this problem and how my idea on solving this problem. Other people might have a different idea. You might also have a different idea. And yeah, that's my idea, and I hope you guys enjoy it. Thank you. Have a nice day.